All right, so today we're going to cover Scarbossa's criteria. So this criteria is one of the more complicated criteria. It's also one of the more complicated ones to say when you read it. But we're going to take a look because it's a pretty relevant one, fairly important. So let's dive right in. So this is how you spell it. First of all, Scarbossa's criteria. Okay. Now, the purpose of this criteria is to tell if people with a left bundle branch block or a ventricular paced rhythm are infarcted. So are they having a STEMI or not? That's kind of the point of this criteria. If you Google it, you will find that there are different versions that exist out there. So what I'm going to do is compare the different versions, see how accurate they are. We're going to talk about the criteria and then take a look at what it looks like in the real world. So the first kind of criteria you usually find is like the weighted criteria, weighted because it uses points to determine whether you're having an MI or not. It's got three criteria. We're going to look at them one at a time. So the first one being, greater than or equal to one lead with greater than 1 millimeter of concordant ST elevation. Concordant ST elevation. So let's take a look. Here's your QRS, T wave right here. We want to look at first concordance, right? We have a QRS that goes up from the isoelectric line. Like the bulk of it is above it. We have the T wave that is above the isoelectric line as well. We're drawing our isoelectric line to compare. And because they are going in the same direction, again, the same direction, we are concordant. Concordant. And then, of course, we look for our ST elevation here as well. It's greater than 1 millimeter, which, again, it's one tiny block. It's bigger than one tiny block. So if we have this, concordance greater than our ST elevation, 1 millimeter of ST elevation, we have 5 points. Get yourself 5 points, and congratulations, you already won, because you only need 3 points to say that, yes, this person's having a STEMI based off this criteria. So 5 points, bam. That is the first criteria. Again, so looking at the second criteria now, we have, greater than or equal to one lead in V1, 2, or 3 with 1 or more millimeter of concordant ST depression. Concordant ST depression. So we draw our isoelectric line. From the isoelectric line, the QRS goes down, the T wave goes down, and because they're going in the same direction, we say that they are concordant. Because they're going in the same direction based off that isoelectric line, we're concordant. And it is depressed. So ST depression right there, greater than one tiny block, obviously, in this particular case. Should you have this in V1, 2, or 3, you get yourself 3 points. So you still win, right? So still, having that STEMI there, or according to this criteria, it says that they are likely. But then we get to the third criteria here. So 5 millimeters or more of discordant ST elevation and at least one lead. So now we're discordant. So we're drawing our isoelectric line. QRS goes down from the isoelectric. T wave goes up from the isoelectric. And we look at the elevation involved here, the ST elevation. So we're measuring from the J point this time. So they're going in opposite directions. It's discordant. We look at the J point. Is it 5 millimeters or more? If it is, then you get 2 points. So not enough to call it, but still kind of significant there. So with this particular criteria, let's look at the stats. So again, the sensitivity, in case you forgot, is a true positive. So if this thing says you have it, you actually have it. That's the number there. And specificity is a true negative, which means if this criteria says you don't have it, you actually don't have it, like how accurate it is, right? 49% sensitivity, 100% specificity. So if it says you have it, it's right about half of the time. But if it says you don't have it, according to this, you don't have it. Like 100% guaranteed, don't have it. And that is, again, a STEMI, okay? or a heart attack, if you will, whatever you want to call it. So that's the stats there. Now, let's take a look at the unweighted version. So the unweighted version is the same thing, does away with the points. And when you do that, here's the change in the numbers. Sensitivity bumps up to 56%, so slightly over half, and then specificity drops to 94%. Still quite respectable, but ain't 100%, right? So there's your two numbers on that particular one, right? Now, that's unweighted. Let's take a look at the modified version. This is the one I use, and you'll see kind of why, because we'll talk about the numbers and stuff. Not a major earth-shattering change, but it does change the last criteria to be even more wordier than the previous one, right? So one or more leads anywhere with 1 or more millimeters of ST elevation and proportionally excessive discordant ST elevation of greater than or equal to 25% of the preceding S wave. So what does that even mean? That's so many words, right? Well, it's good to learn those words because your sensitivity bumps up to 80%, right? So if this thing says you have it, it's right 80% of the time. And if it says if it says you don't have it, you don't have it 99% of the time, okay? So what does it actually mean, though? So we're going to draw our QRS, okay? Again, draw the isoelectric line. You measure the height, or the depth, if you will, of that QRS. So from the isoelectric line to the very tip, the furthest tip, even if it's like a little janky, right? You got maybe a little couple things there. Just go to the furthest tip there. Measure that. Measure from the isoelectric line to the J point. So separate number. Okay, so you've got two different numbers now, two different heights. And what you're going to do is you're going to compare those two. All right. So my S wave, so I take how high my QRS was, right? My S wave in that particular case. Take a quarter of that height. Take a quarter of that height. So 25% of that height. And if the ST elevation is over that number, is greater than the number, so if it's over a quarter of the S wave, that criteria is positive, and you've got a STEMI going on. Okay? So like I drew the 25% mark on the S wave, and all that red bar had to do is exceed that, and it's positive. Okay, because again, left bundle branch blocks and ventricular beats, and pacemakers, they should be discordant normally, but they shouldn't be this discordant, right? It kind of puts some perspective on the height, and this criteria is great because, like, if you have variations in voltage, so like low voltage or something like that, this will factor that in, so it's not so restrictive to that 5 millimeter specific height. This is more titrated to what the patient is presenting with. So this is the great one, a better improvement, in my opinion. So let's take a look at what this looks like in practice, right? So criteria number one, right? Criteria number one, I am looking just here in these leads, and I'm looking for concordance. Concordance. Okay, so QRS and the T wave need to be popping in the same direction. If I have it, it's positive, right? And so looking at these leads, I don't see any concordance, right? So that's good, all right? We're moving on, kind of, although it does say, more than 1 millimeter, but, for learning's sake, look for concordance. Number two, again, do I see any concordance here? I don't, but I'm only looking at V1, V2, and V3. That's the second criteria. Don't have any concordance, good to go. Let's move on with our lives to the third criteria. Now, with this one, we're zooming in here. We draw our isoelectric lines here. Okay, and this is we're just zooming in on these three leads just for an example. Okay, and I'm measuring the height of the QRS. So the QRS, let's take a look at V2, for example, right? I've got 5, 10, 15, 20, like 22, we'll say, millimeters of depth below the isoelectric line. That's how big my QRS is, 22, right? My ST elevation is 3 millimeters. So if I take a quarter of 22, well, it's like 5 point something, right? the height of my J point on the ST elevation is 3, so it's not greater than that number 5 that we got. It's not greater than 25%. So it's a negative. All right. So based off everything that we just did, this person would not be having a STEMI according to this criteria, right? So we're like 99% sure that this person is not having a STEMI. Okay. Going back to that sense specificity there. Now, let's take a look at this. This one's a paced rhythm, right? Okay, so paced rhythm. Whoops. There we go. So paced rhythm, we're going to look at, everything but AVR, V1, V2, V3. Do I see any concordance? Okay. All right. Let's take a look. See? Starting here at V6. It's discordant, 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 discordant. Don't know. Can't really see a T wave because of the artifact there. So we'll leave that as a maybe, right? Discordant, discordant, discordant. Then we get to here, right? Isoelectric line starting from the start of the QRS going across. QRS is going up. T wave is going up. We are concordant right here. So according to this, that's a positive finding, right? And, it should be noted that this particular patient was experiencing chest pain. They were, presenting like it was. They're not just sitting there doing nothing, but, this is a positive finding. So we're going to say like, oh man, this meets this criteria here. So, we would err on that side. But now, let's take a look at this one. Important thing, because this brings a point in I want to make sure everybody knows and does. This is the same patient, just later. And this brings in the importance of serial 12 leads and differences that can occur. Looks a lot different than the previous one. Again, we're looking at our criteria here. We do have this concordance that remains. Everything else is discordant here. But let's take a look at that third criteria, which we really didn't in the first one, and look at the proportionality here. All right, so let's take a look at V2 right here, because this is kind of the easiest slap you in the face one. Isoelectric line right here. Height of the QRS is like 3 millimeters. The J point elevation right here is like 1, 2, 3, 4, 5, like 5 millimeters. So clearly this one meets this proportionality criteria. And you'll see that here in any one of these leads, really. This is, well, even without counting, it's probably well over a quarter of the height of this QRS right here. So this would register as a STEMI, right? This person's having myocardial infarction, and this person actually did. This is a real case of a paced MI, right? So that is Sgarbossa's criteria. That is it in practice. So really good criteria to know and use. Check with whatever your local agencies do to see if they actually use this as criteria for somebody, but gives you a good indication of what's happening.